Let's now discuss monitoring resource usage. When we monitor resource usage, we are asking the question, how hard is the ESXi host working? How hard are the virtual machines working? And what do we do if either is maxed out? What we can do is we can measure utilization either from the inside or from the outside. To measure virtual machine utilization from the inside, we can use Windows monitoring tools, and to measure virtual machine utilization from the outside, we can use the vSphere client performance monitoring tools. Let's start out with monitoring utilization from the inside using Windows monitoring tools. Windows monitoring tools include Windows Task Manager. Many of you are familiar with Windows Task Manager. It shows you how hard your CPU is working and how much free RAM you have for that one virtual machine. If you click on Resource Monitor, which is often called Task Manager's big brother, it can show CPU utilization, disk utilization, network activity, and memory utilization for that virtual machine. If you go to Server Manager, you can run Performance Monitor. And Performance Monitor can show how much memory you're using, how much disk activity there is, and how much CPU utilization there is for that particular virtual machine. But in all three of these examples, we are examining the virtual machine from inside of the virtual machine. Let's now examine the virtual machine from outside of the virtual machine using the vSphere client performance monitoring tools. We can use the vSphere client performance monitoring tools to measure CPU utilization, RAM utilization, hard disk utilization, and network activity, either for the entire ESXi host or for each individual virtual machine. If I go to a particular ESXi host and I select the Performance tab, this shows me that this ESXi host has rather high CPU utilization. So that's for the entire ESXi host. But you can also view resource utilization per virtual machine. So I will select a virtual machine down here. This one's called vCenter Server. And if I click on the Performance tab, this shows CPU utilization for this virtual machine. And you notice CPU utilization is almost at 100%, and you see a little yellow error message right there. Now, just to give myself a little room, let me just slide this to the right. And now we can see that CPU utilization for this virtual machine is pretty high, almost 100%. Memory utilization, it's kind of high, but not terribly high. If I scroll down, you can see that the swap rate is very low, so that indicates there's not a lot of problems with memory. Now, if we look at CPU utilization, that's kind of high in terms of megahertz. If we look at memory utilization, that's up and down, but it's not really going past 30%. If we looked at disk activity, we can see that there is not a lot of disk activity. And if we look at network packets, well, considering the fact that we usually measure bandwidth in megabits per second, this is only 1,200 bits per second, so I guarantee you the network activity is extremely low. And if I scroll all the way down to the bottom, I get a real-time summary for this ESXi host. It shows that CPU utilization is kind of high, RAM is not so bad, disk and disk activity is not very high. Identifying bottlenecks. The bottleneck is the thing that is slowing the system down. So if the user says to you, this system is really slow, we've got to figure out, is the problem the CPU? Is the problem RAM? Is the problem the hard disk? Or is the problem the network? So let's start out, see if the problem is the CPU. Is the problem insufficient CPUs? Well, what we can do is we can go to our individual virtual machine, and under the Performance tab, under the Advanced button, we can look at CPU utilization, and we can see that CPU utilization for this virtual machine is through the ceiling. So if the CPU utilization for a particular virtual machine is through the ceiling, well, we can just add more virtual CPUs to the virtual machine. And you know how to do that. You right-click on a virtual machine, select Edit Settings, and to assign more virtual CPUs, you just click on the drop-down, and that will assign more virtual CPUs to that particular virtual machine. But what if all virtual machines are overburdened? If all virtual machines are overburdened, well, that implies that the entire ESXi host is short on CPU processing power. So if the CPU utilization, if the ESXi host is CPU constrained, we can either, one, move the virtual machines to a different ESXi host, or we can add more CPUs to the ESXi host. And the way we do that is to add another blade to the blade server. And a blade, as you know, is a circuit board which has 2 microprocessors and 4 gig of RAM. So when you put a new blade in the blade server, you are adding 2 processors and 4 gig of RAM. So if the ESXi host is CPU constrained, then add more CPUs. Suppose the user still says that the system is slow. Well, then we have to ask the question, is the problem insufficient RAM? We can look at the ESXi host memory utilization. To do that, we select the ESXi host and we select the Performance tab, and then we select the Memory tab. And then we can see these different variables right here. Now, granted is the total amount of RAM that was issued to this virtual machine. Consumed is the most RAM that this virtual machine has ever consumed, and active is the amount of RAM it's using right now. So you can see it's not using a whole lot of RAM right now. Now, another key variable is what they call ballooning, and let me just explain what ballooning is. If we go to pubs.vmware.com, we see an article that explains what a memory balloon driver does. And what the memory balloon driver does is that when it inflates, it pushes a virtual machine out of memory to make more space for other virtual machines. A balloon driver forces virtual machines to use less RAM. It pushes the virtual machines out of RAM and thus frees up frees up memory for other virtual machines. Of course, it only activates if there is insufficient RAM. So if the ballooning activity is high, then that implies that there is insufficient memory. If we look at this example right here, we can see that ballooning is 0. So it indicates that in this particular example, memory is not a big problem. Another key variable to look at is the swap file. Now, you know what swapping is. When a virtual machine runs out of memory, the data can spill over to the hard disk. Now, if we see that swap used is 0, well, that means it hasn't used the swap file much, and that's not really a problem. Remember, a swap file is when an ESXi host runs out of memory, runs out of RAM, the extra memory can temporarily spill over to the hard disk to a swap file, and this is called paging. But that's only when it's out of memory. You can see that the swap file is 0 right now, which means we are not short on RAM on this ESXi host. The swap file, the swap activity is at 0, which is good. If memory usage on the ESXi host is high, we have to answer the question, is one particular virtual machine taking a large amount of memory? And the way to do that is we can compare virtual machine memory utilization and see if we can identify the memory hog, which virtual machine is taking the most memory. So to do that, what we do is under the Performance tab under Memory, we click on Chart Options. And under Chart Options, we deselect Line Graph, and we select the radio button that says Stacked Graph per VM. And when I click on OK, it shows the 3 virtual machines that are running, and it clearly shows that the accounting server virtual machine is taking much more RAM than all of the other virtual machines together. So if a particular virtual machine is short on memory, well, you can allocate more memory to that virtual machine, and you know how to do that. You right-click on the virtual machine, you select Edit Settings, and all you got to do to increase RAM is slide up the little slider bar, and that can increase the amount of RAM allocated to that virtual machine from 4 gig to 8 gig. Now, suppose that the entire ESXi host is short of memory. If the entire ESXi host is short on memory, well, then what you could do is either 1, move the virtual machines to a different host, or add more RAM to that ESXi host. And of course, the way you can do that is by adding another blade to the blade server. Suppose the symptom, the user still says that the system is slow. Well, now we have to ask the question, is the problem the hard disk? And to view hard disk utilization, we select our drop down and we select disk, and this shows our overall amount of disk utilization. This shows our overall disk utilization. Now, what you can do to monitor the hard disk is to measure disk utilization or to measure latency. Now, when we measure latency to determine disk performance problems, we can monitor 2 disk latency counters. One is the kernel command latency, and that's the average amount of time spent in the VM kernel inside of the ESXi host per SCSI command. And a high number, meaning greater than 2 to 3 milliseconds, means that the data is not getting out of that ESXi host fast enough. And then another key variable is physical device command latency, and that's the average amount of time the physical device takes to complete a SCSI command. And a high number, meaning greater than 15 to 20 milliseconds, means that that disk array is not fast enough, so you might want to get a faster disk array. To add latency counters, what we do is we go to our chart and we click on Chart Options, and then we click off on the checkbox for kernel command latency and for physical device command latency. And now we can see there is physical device command latency and kernel command latency. Now, the danger threshold for physical device command latency was 15 to 20 milliseconds, and we haven't hit that at all. So that's not a problem. The disk array doesn't seem to be overburdened. But when we look at kernel command latency, that is to say inside the VM kernel, the danger threshold is 2 to 3 milliseconds, and oh my gosh, it's all the way up to 20 or 30. So this implies that the data is not getting out of the ESXi host fast enough, so we might want to get a faster technology such as fiber channel, which connects us to the disk array. When we monitor the hard disk, 2 key variables to measure are kernel command latency and physical device command latency. And if we do find that disk utilization is through the ceiling, then we can, 1, move the virtual hard disk files to a different data store, or we could improve disk performance by implementing disk striping on the disk array, or we could get faster hard disks, upgrade from SCSI to SAS devices, or we might want to implement network interface card teaming on the storage area network to get data off of the ESXi host faster, or we could upgrade our SAN technology from iSCSI to fiber channel. Suppose the user still says the symptom is slow. Well, now we have to ask the question, is the problem excessive network traffic? To answer that question, to measure network activity, well, one thing, as you know, you can use Task Manager, and under the Networking tab, it can show how much network activity there is on the network interface card for that one particular virtual machine. And of course, you could run a protocol analyzer such as Wireshark, and that shows you how much activity that there is on the network. We can see here network utilization is about 50%, then it jumps up to 100%, then it drops off kind of low. And then another program you can use is IO meter, and that can measure the amount of IO on your system. Another way to monitor network activity is we go to our ESXi host, and under the Performance tab, we select the drop down and we select Network. And this shows our amount of network activity. Now, if you look at this example right here, we're looking at 1,500, 2,000 kilobits per second. Well, 10 base T is 10 megabits per second. So you can see that there is absolutely no problem here when it comes to network activity. Now, if network bandwidth was the problem, then what we should do is, 1, verify that VMware Tools is installed. 2, we could implement bandwidth throttling, which is something that we did with the virtual disks. We could create separate virtual network, separate VLANs to separate the virtual machines from each other. We could add a second network interface card and implement network teaming for our production network, or we could upgrade the network technology from 1 gigabit per second to 10 gig. Performance optimization, performance monitoring, and optimization. Performance monitoring simply means looking, and performance optimization means taking action if something is wrong. When we perform performance monitoring and optimization, we have key variables, the danger threshold, and then the action that we would take. So if we see the variable of CPU utilization, we can see that the danger threshold for CPU utilization is greater than 85%. And if CPU utilization for a particular virtual machine is greater than 85%, then we should add more virtual CPUs. If the free RAM for a virtual machine is less than 15%, then we should allocate more RAM to that virtual machine. If we find that disk utilization is greater than 85%, then we should get a faster hard disk or implement disk striping. And if we see that network utilization is greater than 50%, then we might want to upgrade our networking technology from 1 gigabit per second to 10 gig Ethernet. Danger thresholds can either be absolute numbers or they can be a deviation from the baseline. Now, what is a baseline? The baseline shows the average utilization over time. So for this virtual machine, we can see that CPU utilization is 20% day after day, week after week, month after month, year after year. It's always 20%. So that is the baseline for this particular virtual machine. Now, a danger threshold is deviation from the baseline. If I told you that this virtual machine is running at 60% utilization, you might say, well, there's nothing to worry about because the danger threshold is 85% and this is only 60%. But if I tell you it's been running at 20% for the last several months, and then one day in a 24-hour period, the CPU utilization tripled, something's got to be wrong. This is called a danger threshold as a deviation from the baseline. It's not an absolute number because 85% is the absolute number. But if we see that there is significant deviation from the baseline, that implies that something is wrong. A danger threshold can be measured as an absolute number, such as 85%, or as a deviation from the baseline. And this concludes our section on performance